Okay, I'm putting together this video for those of you that would prefer some tutorial information. It should mirror what's on the website, and I'm kind of walking everyone through it since this is a solo assignment. Some people might need a little bit more explicit instructions, but hopefully it's going to match the website. I worked with support in order to get an undergraduate account so that I could make sure that I didn't run into any issues with respect to permission and file errors, because I set up the account with my user on OpenLab, and that has faculty privileges, and so I want to make sure that there wasn't any problems with you using a cluster that I set up, or maybe when I was doing it in my test run, I was able to do something because I had faculty privileges that you don't have. So that's the account we're going to use. It's luser, and we're going to walk through the assignment. So the goal of this assignment, as we've said before, is to use a MapReduce cluster to calculate a very simple problem, a very simple task, which is to count the number of characters that are in a file. We're doing this because the next assignment we're going to build a posting list. So let's go and walk through the different steps that are on the website. All right, so the first thing that you want to see is that there's a question of what file are you going to be counting the characters of. And depending on what the last number in your student ID is, you're going to be counting the characters in a different file. The last number of your ID is here, and the file is next to it. All of these files are text files, so we don't have to deal with HTML tag issues. Everything in here should be counted. They are, however, Unicode files, and so you may run into international characters, which you should count each of them separately. This is a one-person assignment, so everyone needs to figure out how to do this. When you output your text, you're going to want to sort it according to the sorting that Java provides with Unicode characters. All right, so the first thing that we want to do is we want to create a fresh Eclipse workspace. So I'm going to go ahead and do that. Bring up Eclipse. All right, and the next thing we want to do is we want to download the source code for Hadoop. We need both the source code for Hadoop, because you're going to program with it on your local computer, in this case my laptop, and you also need the binaries for Hadoop, because you're going to put the binaries on OpenLab when you want to run your program and connect it to my cluster. All right, so let's go ahead and download this source code. We're going to download the stable 2.0 release. And we're going to get both the binaries, which are located here, and the source code, which is located here. If you want to check the integrity of these files, you can also download the fingerprints. I did that offline, so I'm not going to do it while we're watching. Okay, so if we see, they're downloading. You can tell on the bottom of my Chrome bar here. And great, now we're there. Okay, so the next thing, we need to import a new Maven project from the source code download. Okay, so what I'm going to do is I'm going to see what I got. All right, I'm going to move the source code. I have a copy left over from before. I'm going to move the source code to my directory where I'm doing my work. Okay. Open a file browser. So you can see that in my workspace directory here, if I refresh, I should see it show up. No, I won't show it because there's no project. I am going to unzip that file in my workspace. And then I'm going to come over here to Eclipse, and I'm going to import. See that my source code got expanded. I'm going to close this window. And I'm going to import a new Maven project from an existing Maven project. If you don't have this option, it's because you don't have the Maven integration for Eclipse installed in Eclipse, and you need to install the M2E software in Eclipse by going into Eclipse's marketplace and installing it as a plugin. I do have it installed, so I'm going to find the code that I just downloaded. And it's going to take a few minutes for Eclipse to process everything and import it into my directory. While it's doing that, I'm going to remove the source code file just to save some space on my computer. Okay, found a bunch of projects here. We're going to import them all. We're going to have some errors, but it doesn't matter. We only need a few of these projects to work cleanly. Some of those errors have to do with the integration between Eclipse and Maven. Okay, great. So we did that. We downloaded the source code. We imported a new Maven project from the source code download. And we had Maven installed, so we didn't have to do that. So now we're going to create a new Java project called charCount. This is ultimately going to be our project. Use 1.7. Everything looks good. And we will finish. Okay, there's no code in there, not shockingly. Now what I want to do is I want to take the code from Hadoop, MapReduce, examples, so on and so on and so on, word count Java. I'm going to copy that to my project, which I just made. Okay, so let's see. I want Hadoop, MapReduce, examples. Here we go. And I want Java examples. Here we go, word count. I'm going to copy that. I'm going to put that in my directory. And we're waiting for something to happen. Not sure what's going on. Okay, looks like it's building a bunch of other projects. Close that out. Now we see we've got word count here. All right, so we moved that. So that what we want to do now is we want to change that to charCount. Let's bring it up. Okay. I'm going to refactor this and rename it. We're going to call it charCount. Great. Okay, now, in order to get rid of all these errors, we need to add two projects to this project. All right, the first one we need to add is we need to add Hadoop-common. So we're going to come to our charCount project, and we're going to go to Properties. We're going to go to Java Build Path. We're going to say we need some projects on here. We want, oops. We're just going to let that go. We want Hadoop Common, and we want Hadoop MapReduce Client Core. Great. All right. The next thing it says here is make any other fixes you need to make so that charCount compiles but still counts words despite the name. All right, so what do we have here that needs to be fixed still? Something about other arguments. Okay, let's see what we need to do to fix that. Okay, so what this error is saying is that it can't resolve a particular class that's required indirectly from the required class files. And so what I'm going to do in order to get access to that class is I'm going to come over here to Hadoop Common, and I'm going to come down here to Maven, and I'm going to update that project. And I want to update both Hadoop Common and the other one that we just included, which is Hadoop MapReduce Client Core. All right, we'll let those run. And while they're running, I need to change the build properties of those two included projects. And what I need to do is I need to have them export their Maven dependencies, which are the libraries that they depend on. So Hadoop Common uses libraries, and I want it to export it so that when I include Hadoop Common, I also include the things that Hadoop Common includes so that everything compiles. So that's the first one. And then on my Hadoop MapReduce Client Core, I'm going to do properties and do the same thing. I want to export the Maven dependencies. That means that when this project has files that it includes, when I include it from here, I'm going to include everything that this includes as well. Okay. All right, it's building out the workspace. And you can see that all the errors have gone away. And I just have a warning because I'm using this in a way that's been deprecated, but it's still supported for now. Great. All right. So I made the fixes I needed to make for char count to compile, but it still counts words. Now when I try and run this as a Java application, I'm going to get a usage error because this isn't a program that's designed to be run in a laptop. This is a program that's designed to be run on a Hadoop cluster. But I'm going to try and run it so that I get a run configuration automatically. Okay, that's the error that I expected, so everything's good. Here's the error that I expected. And now what I'm going to do is I'm going to export this word counting program to a jar so that I can run it on the Hadoop cluster to count words from a file using Hadoop. So I'm going to do that by right-clicking and exporting this as a Java runnable jar. One important step here is that a couple important steps. We need to pick the launch configuration, the one that I just used. I need to tell it where to put this file. I'm going to put it in the directory where my code is. And I don't want extract required libraries into generated jar, and I don't want package required libraries into generated jar. I don't want any of the libraries to come with it. And the reason why is because the Hadoop cluster's got its own libraries, and I don't want to package libraries in my jar that are going to conflict with the cluster. So I'm going to go ahead and put it in a subfolder next to the generated jar, and then I'm never going to use that subfolder. So let's finish that. All right, so it's putting out char count. All right, so what we did there, so we completed this first section, and what we did is we created a sample MapReduce jar. So this is a library file that has instructions for using the Hadoop cluster. We're going to load it onto the Hadoop cluster in order to get it running. In order to get the Hadoop cluster running, though, we're going to have to do some work as well. So I'm going to temporarily send Eclipse away and bring up some terminal files. All right, and the first thing that I need to do is I need to move some files onto the Open Lab cluster. I'm going to go ahead and switch. I'm going to go ahead and switch into my workspace, switch into the project that I just made. I'm going to look for the jar file. There it is, great. And I'm going to put that on the Open Lab cluster with my temporary user account. You'll have your permanent user account. I'm just using the L user account because it has undergraduate privileges. Okay, I'm going to open up that connection. I'm going to put my jar onto the remote machine. I'm going to quit. All right, the next thing I need to do is actually the first thing I need to do, I did that out of order, sorry, is I need to get an input file. What's the file I'm going to use? What file am I going to count the characters for? I need to get one. So what I'm going to do is I'm going to save that file. This isn't the one that I need for my assignment, but this is just one that I can use for now. It's downloading. Go ahead and move it from my downloads. here. All right, I'm going to go ahead and put that onto the OpenLab cluster as well. Quit. All right. So now I've moved my jar, I've moved my input file. Oh, I haven't moved the Hadoop binary to OpenLab yet, so let me do that. My Hadoop binary is located over here. I downloaded it, and I am going to move it from my download folder to here. There it is, and now I'm going to put it on to OpenLab. Okay, takes a little while. It's a big file. All right, it's all done. I don't need that anymore, so I'm going to delete it off my local hard drive. Okay, great. Now if I come back to my instructions, it says I need to log into OpenLab and I need to uncompress the Hadoop binary file. Great, let's do that. Oh, not SFTP, that's used to transfer files. I want to actually create a window. All right, let's see, where am I? I'm in my home user directory. Let's see what we've got here. Lots of people use this directory, so I'm just going to make a temporary file for me so that other people who use this account in support don't get confused. I'm going to change into that directory, and I'm going to move my jar to here. I'm going to move my Hadoop binary to here, and I'm going to move my input file to here. If I look, there they all are. Now I'm going to extract the binaries from Hadoop, and I'm going to do that using a command called tar that unextracts things from an archive file. And I'm going to use the options X to extract, V for verbose, O to overwrite any files that are there, F to take input from a file, and Z to take input from a compressed file. And then my file is going to be this one. Whoosh. All right, what do I have? All right, my Hadoop has been extracted, so I'm going to delete the archive file. And my next instructions say to edit the etc Hadoop core.site XML file so that the location of the distributed file system is exposed by adding this XML property. Okay, that's not hard. Move into Hadoop, change into the etc directory, change into the Hadoop directory, and I'm going to edit the core site file. You might use a different utility than VI to do that. That's what I'm going to use. All right, cut and paste that. Come down to configuration, add it into the configuration. Okay, and we know that Francis Griffin is where the source of our distributed file system is, and that's provided. So that should be all I need for that. So I'm going to save that, move back to where I was. Where am I? Type the pwd directory, go up one more. Okay, great. Now what? All right, now, okay, what do I want to do here? Look to see what's in the distributed file system with the command bin hdfs dfs-ls/. Okay, so I'm going to move into my Hadoop directory. I'm going to type the command bin.hdfs. I'm going to give it the option distributed file system. I'm going to give that the option -ls to look. That's the same as the list directory for the normal file system. And then I'm going to use the / to say the top of the distributed file system. The distributed file system is one big virtual hard drive that is partitioned across all of the nodes that are participating in the MapReduce cluster. By using this command, it makes it seem like it's one hard drive, one directory structure. But in fact, these files are distributed all over the different nodes in the cluster. So let's see what's there. Java home is not set and could not be found. Oops, that's right. I forgot to switch in make sure that I'm using the right version of Java. So let's see, module avail Java and module switch to Java 1.751. Great. Now let's try and look again. A bunch of warnings. That bothers me. But here at the bottom, I see in my distributed file system that there's a directory called /user in the distributed file system. If you come back up here to the assignment, you see that you can get rid of some of those warnings by replacing this file that's located in the Hadoop directory that you just extracted on OpenLab with one here. And the one that I have here, I built natively on OpenLab to try and get rid of some of these errors. These errors are being caused because we're running a binary that was compiled for a different architecture on our OpenLab machine. Our OpenLab machine can accommodate it, but it gives us a lot of warnings. So to get rid of those warnings, I'm going to download a native library that's going to my laptop. And now I'm going to upload it to OpenLab. And I'm going to move it in my OpenLab window from where I just downloaded it to where I indicated it needed to go over here. Okay, and now when I run that list command, I don't get the warnings. Okay, great. So now I see there's one directory called user. Let's see what's in that user directory. Do the same ls command there, and I see, oh look, there's a bunch of people who have created directories in there, including one for my normal account and then one for the account I'm currently using. Okay, let's go back to our instructions. Our instruction says make your own directory in the distributed file system. Okay, we're going to do that with the command bin/hdfs dfs make directory, and we're going to give it the file path /user/luser. Now this already exists, as we just saw from our ls command, so we're going to get an error. But that's what you'd do if you don't have one yet. Great, file exists. That's what we expected. Okay, now what we can do is we can look to see what's in that directory by adding the full path. Okay, I've got an input directory and an output directory. The other thing that I could do is I can look at the file structure by using a web browser that is interacting with the Hadoop cluster. So here's the user directory, here's the directory I just made, and you can see that there's input and output. This is convenient for browsing, but you can't upload to here. You have to use the command line to upload. Okay, so that's convenient, helps you know what's going on if you get confused. All right. That was the file system. Okay, now let's make our own input directory. Well, this already exists, as you can see, but if I wanted to, I could make a directory, input directory, using that command. All right, and then the last thing that I'm going to do is I'm actually going to remove my output directory so it doesn't conflict when I go to run my binary. I'm going to use the command rmdir for remove directory. Okay, the next thing that I have to do is my input. When you use the MapReduce cluster, your input has to be on the distributed file system. How do we get something onto the distributed file system? Well, we use the copy from local command. So if I look at my directory in OpenLab, where am I? I'm too far down. Let me go up a directory. And I look here, I see, there's my input file. I need to get that input file into the distributed file system. So I'm going to go back into my Hadoop directory. I'm going to run bin/Hadoop distributed file system with the distributed file system command. It's a little redundant. Use the command copy from local. And I'm going to give it the file that's on my OpenLab directory, up one directory, then input file. And then I'm going to give it the destination in the distributed file system, user/djp3/input. That's going to move the file into the distributed file system. Uh-oh. Oh, I got a permission denied error. What happened? Oh, well, I'm operating as the user L user, and I tried to put it into DJP3's directory. So that didn't work because I don't have permission to write to DJP3's directory. So let's put it in the directory associated with my current user account, which is L user. Okay, great. So now let's just make sure that that ended up there by doing my ls command. And I can see, if all goes well, great. I've got two files, input.txt and inputfile.txt. Input.txt is left over from when I was practicing. So I'm going to go ahead and remove that so we don't get confused. I'm going to use the distributed file system command, rm, and I'm going to remove the file user, loser, input.txt. Okay, deleted the file, and if I double check, I can see the only thing that remains should be the input file.txt. Great. All right. So that completes this section. So what I've done is I've put the binaries in place. I've added a particular property of the binary, and I've put my input file in place. Now I'm going to run my sample program. So the way I'm going to do that is I'm going to do bin/Hadoop. I'm going to point it at my jar, which is located one file up, and I'm going to tell it where the input is. And I'm going to tell it where the output should go. Sorry. Oops, I got an error. What error did I get? It says that directory already exists. Well, that's a problem. I must have made a mistake somewhere along the line. I'm not sure what I did, but let's try and fix that. Let's go ahead and remove recursively and force it to get rid of any directories or any files that are there. Output. Okay, and then let's try and run my jar again with the same parameters. Okay, this is good. Shows that something's happening. Maps and reduces. 100% done, and a bunch of statistics. Okay, wow, I wonder if that worked. Well, let's go to the file system, see what we got. Go into user, L user, and output. It says success, and it says this file here, this reduce file 000, and if we open it up, we can see it's gone through and it's counted all the words that it's found, and it's put the count at the end of it. Huh. So MapReduce did its magic there. Whoa. And there are all the counts for all the words that are in the input text. And you see there's a lot of chunks. It stores it in chunks in the file system. I can download this file here using the web browser, or if I come back here to my command line, I should be able to use the command binary Hadoop distributed file system. Let's make sure it's there. Do ls/user/loser/output. Okay, and I don't actually know exactly what the command is to remove it. It's probably copy from remote, maybe, or copy from distributed file system. But I'm going to do dfs help, see if I can get some help on what the command format is. And I can come back up here and see, move to local, copy to local. That's what I want. Okay, so I'm going to do bin/Hadoop distributed file system, copy to local /user/loser/output/ can't remember what the file name is. Let's see if it works with star to here. Let's see if it came out. Oh, there it is. I got the success file. And I got the reduction file that should have all of the words and the counts for all of the words. All right, so that would be my answer. That file, that part-r would be my answer. Except that what I did is I counted words. And so now what I have to do is I have to go through my file here, my character count file, and change it so that rather than counting words, it's counting characters. Once I have my code fixed, I export it as a jar using the functionality here, and I follow that same process that I just did, but making sure that it's being applied to the correct input file and it's counting characters instead of words. And then I take that output and I turn it in on checkmate. And that should be all it takes. There's a little bit of complexity that I haven't described here with respect to changing the code itself, but it's pretty small. And what remains to be done now is to look at the structure and the architecture for how the MapReduce code works and to change it. All right, I think that's it. I'll go ahead and post this on YouTube and put a note up on Piazza that it's here. Thanks a lot for your attention. See you in class tomorrow, or if you watch this later, next Tuesday or Thursday following.